Living in Portland with 300 rainy days and dark winters, it can really weigh down on employees. And so being able to work in an environment where you have a lot of light available to you makes a huge difference.
So the story of the Portland building was, it was a dark, dreary building. It just was not a positive work environment.
Challenges with opening the building to more transparency. You don't know, originally the building looked like it had a lot of glazing, but there was just little 4x4 windows that were actually black glass, and so very little light got into the building.
Well, the outside frame is the structure of the building. You might as well start over. That's what holds the whole mess together.
So the existing building is a mild reinforced concrete building, which uses what's called a moment frame to resist lateral forces. So effectively, the entire building is made up of columns and then waffle slab, which is a type of concrete slab, heavily used in the 70s and 80s. But really all the lateral forces transfer from the slab into the columns, which is not the most effective way of doing that, because if you think about if you put a plate on top of a pencil, it doesn't take much to just knock that pencil over, right? Even though it was designed to resist lateral forces, and back in the late 70s, those were primarily wind-driven forces, they're not as effective at resisting seismic forces. One of the standards in today's construction, especially in concrete buildings, is utilizing shear walls, which are much more effective at transferring that lateral load into a length of wall, and then taking that lateral load all the way down the wall into the foundation.
It was proposed to do a new shear wall around the passenger elevators and stairs that are in the center of the building.
We worked to design a process in which we could open up the floor slabs and kind of cut the floor away from their supporting columns 3 floors at a time.
We recognize the fact that this building houses so many of our city engineers, and we had a lot of engineers very excited about the structural upgrades, and so that actually drove the decision to expose the seismic upgrades. The shear wall going all the way up through the core is exposed concrete, and we did that so that you can see and touch and feel the experience of that seismic upgrade.
There's 90 tons of rebar that go through that central shear wall core, and it goes from being about 24 inches thick in the basement to around 18 inches thick at the top floors. It is a stout and amazing piece of structural engineering.
So when we moved the shear wall that was on the outside to the interior, it allowed us to take all the glazing on the outside that looked like it was really glass, but really was spandrel glass, which means no light comes through, and open that up. It allowed all the floors now to actually get all of that light.
Seeing the amount of daylight that could have been getting into the building but was just covered up with drywall and spandrel glass really emphasized the amount of light that could have been getting into the project, and that we ultimately were successful at bringing into those floors.
Back in 1980, we were going through the oil crisis, and so at that point in time, a lot of decisions were made around choosing glazing that was very energy efficient. Fast forward to now, technology's improved so much that now we can actually have clear glass that's performing at that same level, but now it's allowing that natural light into the building. It's allowing all the users to get that natural light. We lowered all the partitions so that light comes deeper into the space. We opened up the ceilings. We painted everything out white so it's reflecting. And the floors just feel very different. Much more light is bouncing around.
At the beginning of the project, there was a survey done of employees to really list the biggest problems that they had in the building. And the one that came back resoundingly #1 was the lack of natural light. I hope they would agree that we really knocked that one out of the park.
They wanted shaded glass. There is nothing worse than tinted glass. What we should do with the Portland building is take out all the glass and put in clear glass. The floor to ceiling height is low. It's low because of the budget. It's not low because of the architect.
On floors 4 through 14, which are the primary office floors, they had acoustic ceilings that were, in the 8-foot to 9-foot range. There was cubicles that were 5 feet tall everywhere. Everything was very beige. The lighting was kind of average, and so what happens is you just had a floor that was very uninspiring. The first thing we did was just remove the ceiling and really open up the space. This building has these beautiful ceilings that were hidden forever, and now they're totally exposed, and the waffle slab adds a texture and a light quality.
We move around 60% of our workforce every year. Our bureaus grow and shrink based on budgets, based on initiatives, based on the needs of the city. The floor plates, what we did is we standardized how many people are supposed to be per floor. They can be private offices, or they can be huddle rooms, meeting spaces, or they can be storage spaces.
This allows for bureaus to grow and shrink as they need, to add employees, to switch between floors, and really understand how they all work. It really supports an agile, constant change situation, which is the way business is today. That's true in tech, it's true in government, and so really the system now supports that versus being stuck with something that's going to be outdated in a few years. So it became really focused on the employees once again.